You set up the slideshow. And as soon as it comes up, we'll be going. There we go. All right, this is not the example 6 that's in your text. So let's do the example 6 that's in the text. Find the inverse function of f of x is equal to, let me get my pen set up. The system just isn't working very fast today. There we go. Okay, it's 5 minus x, not 5 minus 3x, over 3x plus 2. Okay, sorry about using that, but it just keeps it. Okay, this is the one that's in your text. We're supposed to find the inverse function of that. We went through this last time. What's the first step? What's the first step in finding an inverse function? This is Jermichael, right? Okay. Anyone else come in since I called roll? What's the first step? Finding an inverse function. Any ideas? Okay, not quite, but you're getting there. First thing you got to do is make sure it has an inverse. What has to be true about the function for it to have an inverse? It has to be a one-to-one function. 1 to 1. Okay. Has to be a one-to-one function. Okay. What do we mean by that? Okay. Has to pass the horizontal line test. Okay. Now we haven't graphed this kind of function too much, but we can. I'll give you a few hints on how to do it. I'm going to rewrite it slightly, not that I like to do it this way, but it's helpful a little bit later. I'm going to rewrite this as minus x plus 5 over 3x plus 2. Now, that's not necessary to do, but it might be helpful in what we're doing. When we're graphing something like this, what is one thing we've got to watch out for always? Deals with domains. What is our problem, the thing that we have to watch out for in our domains of functions? What can you never do? So far, two things. Say again?
Get the same answer from one domain.
What's that?
Get different answers from one domain.
Okay, yeah, that would, for a function value, you can only have one answer. That's going to be a function. This is a function. What we're wondering about, is it a one-to-one function? It can be a function and not be one-to-one. We've got to find out if this is. But what, in determining the domain of the function, what is one thing you've got to watch for? There's actually two things we've covered. There'll be more coming up later. One thing you can never do anywhere in mathematics has to do with it was a long weekend, wasn't it? Did y'all go to Dallas too? No, okay. You can never divide by 0. Okay. Do we have any division in this problem? Yes. And you have a variable down there. So you have to make sure that that denominator is not equal to 0. So exactly what I just said, 3x plus 2 cannot equal 0. How do we solve that inequality? Subtract 2 from both sides of the equation, and that leaves us with 3x cannot equal negative 2. And now what? Divide by 3, and that says that x cannot equal negative 2/3. Okay. So what we're going to do is draw the graph of this. Okay? I'm going to tick off a few points. Not very evenly spaced, are they? Okay. Negative 2/3 is right about there. X cannot equal negative 2/3. Agreed? Okay. Now, on the graph, that means that nowhere on this graph can X equal negative 2/3. So that line is called a vertical asymptote. You can't touch it, you can't cross it. Okay? That's the first thing we're going to do. Okay? Second thing we're going to do. Oh, it doesn't matter what order. What's a very easy point to find on any function? The what? The origin? That's on a graph. I don't think the origin's on this function. Because when x equals 0, which is what I was getting at, what is your y? X equals 0, what's your y? It was a long weekend, huh? Okay. No more partying on weekends, okay? At all, okay. Can't you do that? Put in x equals 0, what your y becomes? X equals 0, what's the y? 5/2, okay? When x is 0, those terms disappear, and you have y is equal to 5/2. Where would I plot that? Well, let me go back to black. Okay. Where is 5/2? 0 5/2. Go up 2.5, right? 5/2. There's the, what do we call that point? Where x is 0, it's on the y-axis, what do we call that? Y-intercept. Okay, one of the easiest points to find on any function. Set x equals 0, see what the y is. Okay, so we got a point there. Okay, now, the other one, the other intercept would be that's the y-intercept. The other intercept would be the x-intercept. How do you find that? Yeah, the y-intercept, you set x equals 0. So the x-intercept, you set y equals 0. Where's your y there? F of x. Set that equal to 0. So for this to be 0, what does that tell you about this over here? Pretty obvious thing. For this to be 0, doesn't matter what the denominator is, that numerator would have to be 0. Okay, right? So, let's do that. The numerator, which is minus x plus 5, is equal to 0. How would you solve that equation? Help me, help me. You could subtract 5 from both sides. I'll do it. And what does that give you? Negative x is equal to negative 5. Are you through? No. What would you do next? Divide or multiply by minus 1, and that gives you x equal 5. So where will we plot that? Right there. Go right 5 and don't go up or down at all. There is x equal 5. So we've done the vertical asymptote, y-intercept, x-intercept. These are all pretty easy things to do. The next one we haven't done yet, we're going to do in the next chapter, but they're giving it to you now, so I'll give you a heads up on it. Okay? The next is a horizontal asymptote. Now what that means is what happens to the function when x goes really, really large. Very large to the right, to the left, or right, left, wherever, okay, very large, okay? We call that the end behavior, okay? And at the end behavior, here's something to remember next time when we do it. It all depends on the leading terms. So you look at the ratio of the leading terms. That's why I rewrote this so you can see it. There's the leading term. What's the ratio of those two numbers? Just those. Forget about that. In the long run, they don't contribute much at all. The x, as it gets very big, this dwarfs what that's doing. So what's the ratio of that term right there? The leading terms. People listening at home can't see my finger. What's that ratio? Second? Well, -1/3, which is called -1/3, right? There is your horizontal asymptote. Y is equal to -1/3. -1/3 is right down about there, right? Now, so let me get my red ink back again, and that will be my horizontal asymptote. Okay? Now, a little bit of difference between a horizontal and vertical asymptote, besides their orientation. The main thing is you can touch or even cross a horizontal asymptote, but that's where the function's going in the long run. Okay? It's long loop. No, okay. That's where it's going. So, we know right now from what we've got on the board, the 2 points and the 2 asymptotes, we know where it's going in the first quadrant. Okay? Because, let me get my black ink again, it's going to the vertical asymptote here. It can't touch it, so it approaches it, and it's going to the horizontal asymptote there. So there's what half of that function looks like. Is that 1-to-1? Yes. Why? It passes the horizontal line test everywhere. Fantastic. We just got to figure out what's going on the negative side. So what I'm going to do is pick an x that's to the left of this vertical asymptote, like maybe -1. So let's plug in a -1 here and see what we get. Okay? F of -1 would be what? You can use either form you want to. 5 minus a -1 over 3 times a -1 plus 2, right? Well, what's 5 plus a -1? I mean, 5 minus a -1. 6, okay? And what's 3 times a -1 plus 2? Say again? -1. So this will be 6 divided by -1 is -6. So at x equal -1, your y is 1, 2, 3, 4, 5, somewhere way down there, okay? And we know it doesn't cross the x-axis again. It's already, the only x-intercept is over there. So it goes down here and approaches horizontal asymptote that way, vertical asymptote that way. There's your function. Is that 1-to-1? Yes. So we can do a find the inverse function. Okay? Sorry, that took a fair amount of time, but you need to make sure that's true, that it's a 1-to-1 function. It could have been that this was up here. And if it was, would that have been a 1-to-1 function? No, failing the vertical line test almost everywhere. This one does pass the horizontal line test. Everything is a function that passes vertical. But okay, so we've determined that. Okay, that was step 1. We got several steps to go. Any questions on that? Can I go on and erase it? Yeah? Okay. Oh, I probably shouldn't have done that. Okay, I forgot. This is 5 minus x and 3x plus 2, right? Yeah. So we have determined it's a 1-to-1 function. It does have an inverse. What's your next step? Wow, Thursday was so long ago. What's the next step? It's a real easy one. It's what I've been asking you all term. Most important thing to know about functions. What is f of x? Y. Why not? Okay, you put a y there instead of f of x. So you write y is equal to 5 minus x over 3x plus 2. All right. Y'all remember that well. Okay, what was the next step? What is true about inverse functions? Especially if we wrote them as ordered pairs. What would we do to write the inverse function of an ordered pair? Say again? What do you mean by that? Negate it? Aha! Flip them. And what represents the domain? The what? Not the numerator. Which variable? X, and which represents the range? Y. And if you're going to flip them, guess what we do? Exchange x and y. So what will that become then? X equal 5 minus y over 3y plus 2. You got it. Okay. Next. What do we usually solve for? Okay. This is solved for x. We normally solve for y. So that's what we got to do here. How would you go about solving that for y? Well, that means it's isolating the y, getting all the y's on one side and everything that's not a y on the other side. So what would be your first step? What's the messiest thing about that problem right now? Yeah, the denominator. We don't like denominators when we're trying to solve for y. So what would we do? Multiply by 3y plus 2. Multiply both sides by that denominator. Got to do it. If you do it to one side, you got to do it to the other. So these go away there, and that leaves us with, if you can read my writing there, that would be, and go on and distribute, 3xy plus 2x is equal to 5 minus y. Okay, at least we got rid of the denominator, sort of messed up the left-hand side some, but that's better than having a denominator. So what do we do next? What's our goal? Yes, get y by itself. So that means, number one, got to get all the y's on one side and all the thing turns with no y's on the other side. So what would that mean? Say again? A little louder. You may have said it right. I just couldn't hear. Subtract 5? How about let's adding y? Get it on the other side. Okay? And subtract 2x. So we're going to add a y and subtract a 2x from both sides. Will that work for us? That goes to 0. That goes to 0. So what do we have left? 3xy plus y is equal to 5 minus 2x. Okay. What's that?
Could you write it as 3x 2y?
3x 3y? Is that
3x 2y.
3x 2y.
Could you write it that way? Or?
Okay. I don't understand what you mean. This is 3x plus y. Okay. Those
I
are.
didn't know if you could write it as 3x 2y. I didn't know.
Oh, divide this by 3x. Is that what you're saying?
Never mind.
Okay. All right. What's the goal? Get y by itself. How can we do it here? What's the F word? All right. I'm glad you remembered that one. Okay. And what would that be? I'm going to move it up here. What's the common factor in the left-hand side? That's why we did it this way. What? Common factor here. Y. So factor it out, and what do you have left? 3x. Second. A little louder. Help me. Plus 1, very good, is equal to 5 minus 2x. Okay, and what is our goal? Isolate the y. And what do we do next to get it by itself? Divide by 3x plus 1. Very good. But you got to do it to both sides, of course. 3x plus 1 here. Divide this by 3x plus 1. These go away, and that becomes y is equal to 5 minus 2x over 3x plus 1. Okay? Next step is just about as easy as the first step. Well, the second step. Except now, what does that y represent? F inverse. Not f, but f inverse. Because we swapped everything. So this is now f inverse of x is equal to 5 minus 2x over 3x plus 1. Okay? Are we through? It said find the inverse function. That's what we propose that it is. But what should we do, really? And it's part of this algorithm. Check it and make sure it is. How do you check to verify that is the inverse of that? Second? Yeah, I'd rather not. If it's okay, you could. What were you going to say? What's the algebraic way for testing for whether it's an inverse or not? What's true about every inverse function? Composition. Does that ring a bell? Okay, what would that be then? For it to be the inverse, f of f inverse, in other words, the composition of f with its inverse. If it is an inverse, we have to see what that is. What had it better be? If those are inverse functions of each other, what had it better be? Huh? Okay, he's really opposing today. Everything's the opposite. Okay. If you operate on something with an inverse function and then operate on its result with its inverse, you get right back like you started, right? Should get an x. We need to do that and see. Okay? So how do we start this? F of f inverse, where do we begin? The interior. We do f of, what is f inverse? There it is, yeah. 5 minus 2x over 3x plus 1. Now, what does f tell you to do? The f function right up here, what does it tell you to do? Start with, that's what we're doing. We're operating on this thing here, this really complicated fraction, with that f function. What does f function start with? 5, okay? Minus, say again, whatever is inside the parentheses. Here's what's inside those parentheses, so what does that become? 5 minus 2x over 3x plus 1. Okay? Then you do what? The f function says divide by 3 times whatever's inside the parentheses, which is 5 minus 2x over 3x plus 1 plus 2. You see, you take whatever is in here and put that right where the x's are there. Well, that's what was inside that one, so you put this in that place. That's what the f function does. So now we got a bit of math to do, okay? Now, I think I told you before what I suggest, how I suggest you deal with these complicated fractions. Do you remember the technique? No, that was last week. We finished with that last week, right? No. find what's messy about that? Denominators. So let's find the least common denominator in the numerator and the denominator. What is it? In fact, it's the only one you got. A little louder. Second. 3x plus 1. That's the denominator here. It's the denominator there, right? So what do we do with it? It's in the denominator, which indicates division. So we multiply by that least common denominator, 3x plus 1. Up here, but you also do it down here, times 3x plus 1. Okay. Now this isn't quite as bad as you might be expecting. You distribute this, both terms. Multiply this by that, and what do you get? Let's just do it all at once. 15x plus 5. That's the beginning. 15x plus 5. Okay? And then distribute here. When you multiply these two together, what do you get? Those divide away. So you get minus what's up here. And what is that? Minus 5. One more. Minus 5. A little louder. Plus 2x. You got a minus here. Distribute. You got rid of that denominator. So it's minus 5 plus 2x. Right? See it? Okay. So there's your numerator. We can simplify it. We'll do that in a moment. Okay? How about that denominator? When you distribute that on the first term, what happens? The denominator disappears, and all you have is 3 times this, right? So what would that be? 15. A little louder. 15 minus 6x, is that what you said? I'm hard of hearing. 15 minus 6x, okay? And then distribute this, and what do you have? 6x plus 2. Okay? That's a plus 6x plus 2. All right. This isn't looking too good, folks. Oh, maybe. Yeah, it's okay. Let's simplify that numerator by combining like terms. What do you get? Say again? 17x. No, plus 5 minus 5 goes away, right? Right? And in the denominator? 17. And what's 17x over 17? X. 17x over 17 is just x. Ding, 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 ding. That's what we were looking for. X. F of F inverse should be x, and indeed it was. And guess what else we need to do? F inverse of F. Oh, this is so much fun. Yeah, you need to do it and make sure it works both ways. Okay? Now, I'm going to try to save as much as I can, but I'm going to get rid of everything else. Let's get rid of this and that and this and that and that. Okay? And then all the rest of this. The last thing that we need to do is confirm that we did the f of F inverse is equal to x. We've got that. So the next one, the last one, is that I'll cheat a little bit here. Okay. The only reason I'm going to do this is because it was like pulling teeth getting you to do the first one. So I want to make sure you review how to do composition of functions. It seemed like that was a little on the weak side. We did this one and figured out that was equal to x. Okay, all that we did. Okay, so what's the next one we do? We did f of f inverse. Now we do reverse those. Not that hard. F inverse of, help me, f of x. Okay? You did it this way, it's got to also work the other way. Okay? Now, what do we hope this becomes? If it is an inverse function, what will the answer be? X. Okay? Let's see if it does. It doesn't look like it will be, but let's see. Which do we plug in first? The innermost. F inverse of, and what is your f of x? 5 minus x over 3x plus 2. Okay, now what do we do? The inverse function right here starts with what? 5 minus 2. But instead of x, we put what's in the parentheses, which is 5 minus x over 3x plus 2 over, what's the next thing that the f inverse does? Did I hear a 3? 3 times 5 minus x over 3x plus 2. What's the last thing the f inverse does? Plus 1. Using this f inverse function, it starts with 5 minus 2 times whatever's inside the parentheses, that, divided by 3 times whatever's inside the parentheses, that, okay, and then add 1 to it. All right? Now the rest is algebra, okay? What would be your next step? I'm drawing the brackets as a hint. Help me, help me. Say again? What's that? She said I was beyond help. I heard her say that. No, okay. What's messy about that? Denominator. So how do you get rid of them? Multiply by the denominators. Numerator and denominator, 3x plus 2 over 3x plus 2. Why is that a legal move to do anyway? What is 3x plus 2 over 3x plus 2? No? I hope not. Multiply by 0 would wipe everything out. 1! Okay, and when can you multiply 1? Anytime you want to. It doesn't change the value at all. Okay? But what it does do is lose your denominators. So let's do the first one. We first got distribute 5 times that, and what would that give us? 15x plus, did I hear a 10? Okay. And then we have a minus 2 times, and here, when you distribute this by this, you lose those denominators, and that just is minus 2 times 5 minus x, right? Okay, that's divided by, when you distribute this times this, there you lose your denominator, and that leaves you with 3 times 5 minus x, right? Plus, and that's just 1 times that, so that'll be 3x plus 2, right? 1 times that is actually right. So just write that down. Okay, let's do that little bit of distributing we need to do here. That'll be a 15x plus 10 minus 10 plus 2x, okay, over, this will be 15 minus 3x plus 3x plus 2. Now, how can we simplify that? Plus 10 minus 10 adds to 0. Minus 3x plus 3x adds to 0. What is your numerator left to be? 17x, that sounds familiar, over 17. And what does that come out being? X! Ding, 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 ding! You got it again. Okay? We have confirmed that these two functions are inverses of each other. F of F inverse gave us X, and F inverse of F gave us X. Both of those produce the identity function X, therefore they are inverses of each other. Okay? Make sense? Done. Find the inverse of that function. That's what we have. Let's see what the book found. F inverse to be 5 minus 2x, yes, over 3x plus 1. Yes. And they tell you, check that those two things are true, and indeed we did. There is a checkpoint here, folks. I would highly recommend you do that, okay? It was hard enough getting you through this one. Be sure you do that checkpoint. If you have trouble with it, the audio-video solution is at larsonprecalculus.com. All right. Now, I think we've already done example 6, so we're just going to walk through that. See, the first thing they did, they drew the graph to show it was an inverse function. We already, the one-to-one function, we already did that. And y'all still didn't remember how to do it. Okay. So, and this was how they did it. All those steps that we did before. You know what? This was the function we just did, isn't it? Okay, look at this. I didn't realize this. They wrote this function, which wasn't our function, but they worked on the one that was. And that's exactly the function we had. If you remember, this function here, see, that's different from the function they had there. It's the one we did. So this is just like we did. Now, this line here is just the horizontal line test. That's all they did. What they did, your horizontal asymptote was minus 1/3, if I remember right. Your vertical asymptote was negative 2/3. Okay, y equal negative, x equal negative 2/3, y is equal negative 1/3. Your y-intercept was at 5, I believe it was, wasn't it? No, 5/3. No, y-intercept, yeah, it's 5. Okay, and that's sure enough. I think they've got their scaling wrong here. Because y-intercept for x is equal to 0. No, it's 5 halves, 2 1/2. So that's exactly right. 1, 2 1/2. 2 1/2 is the y-intercept. The x-intercept is 5, and there it is right there. Okay. So yeah, They got all the points we did. They just didn't show the vertical and horizontal asymptotes. And that is a one-to-one function. So they did the first step. This is exactly correct. It's the wrong function there, but the right function down here. See, this was the one from the old edition. This is the one from the current edition. Okay? So, there's our graph. It's one-to-one. We can proceed. Next step, it passed the horizontal line test, so they wrote the function down again. Ah, good. Extra step there. And what's the next thing we did? You tell me. Once you verified it was a one-to-one function, by graphing it, showing it would pass the horizontal line test, they wrote it down. What's the next step? Set f of x equal y. Perfect. There it is. Next step. Oh boy, it was a long morning too, huh? What is it? Exchange the x and y, and that's what they do next. There it is. X on the outside, y is on the right-hand side. But now we have to solve for y, so we got to do some work. Multiply by that denominator, and that gives us x times 3x plus 2 is equal to 5 minus y. Then you got to distribute through, right? So it'll be 3xy plus 2x equal 5 minus y. What's the next thing we're going to do? Get all the y's on the one side and all the non-y's on the other side. So the y's on the left, everything without a y on the right. And that gives us 3xy plus y is equal to 5 minus 2x. Okay, now what? What's our goal? Second? Yes, get y by itself. Isolate that y. We're on naked y. So what do we do? What's the F word? Factor out the y. Okay, that gets it almost by itself. Y times 3x plus 1 equals 5 minus 2x. You sort of did one step to isolate it, and now the final step will be, second, divide by the 3x plus 1. There you have it. Okay, it's not quite the final step. What's the next one? The easy one? What does that y represent now? What were we looking for? F inverse. So change the y to F inverse, and we got it. Okay, that goes so far as to find it. Then you have to verify it. And guess what they say? Check that F of F inverse is equal to x. F inverse of F is equal to x. We did them both, and they sure enough came out x. Both of them. Got it? Good deal. All right, that was the last slide on the slide set, but there is another example, example 7. Oh boy. Finding an inverse of a function algebraically, find the inverse of this function. F of x is equal to the square root of 2x minus 3. What's the first step? First step. It said find the inverse. Is this guaranteed to have an inverse? No. What must you do? Verify that is? Yes, that it passes the horizontal line test, that it's a one-to-one function. So that almost means graphing it. Okay? Okay? I'd rather not, but let's do it. Okay? Before we graph it, let's focus on domain. What's the domain of this function? Is there any restriction to the domain? Is this an all real number one? Why not? Because, yeah, you cannot have a negative inside a square root. So let's write algebraically what you just said. What's inside the square root? 2x minus 3. How can we write algebraically cannot be negative? Is greater than or equal to 0. You got it. And now what? Solve for x. Add 3 to both sides. And that gives us 2x. Now it's greater than or equal to 3. Divide by 2. And we have x is greater than or equal to 1 1/2, 3/2. Okay? So I'm going to start my graph here, realizing that x has to be greater than or equal to 1 1/2. Right there. That's where it's going to begin. Okay? So right there, if I plug in 3/2, that's going to be easy. Alpha 3/2 would be 2 times 3/2 would be 3 minus 3 is 0. Square root of 0 is 0. Okay. That was easy, and that's why that's my point. Okay? Now, the next value I want, now this sounds like I'm doing it backwards because I'm really lazy. That's what I'm doing. The next value I want inside here is a 1. I want that to be a 1 because I know what the square root of 1 is. So if you let 2x minus 3 equal 1, what does that mean? What would you do? Add 3 to both sides. That would be 2x is equal to 4. That's a 1 there, right? Okay? And then x equal 2. Okay? So when x is equal to 2, we know that y is going to equal 1, don't we? Because if you go back and plug it in, you get a 1. Square root of 1 is 1. What's the next value I want in here? Because I'm really lazy. We've done 0, we've done 1. What's the next value? It's really easy to take the square root of. What's your next perfect square? 0, 1. 4 is not, 2 is not a perfect square. I said it. 4. Okay, you want that to be 4. So guess what? This time I put this as be a 4. And then this becomes a 7. And this becomes a 7/2. I'm being real lazy, which is 3 1/2. Okay? So when x equal 3 1/2, there's 1, 2, 3. 1, 2, 3 1/2. Here, we know that's going to be a 2 because the square root of 4 is 2. See, I told you this is a real lazy way to do it. This is getting messy. So, what's the next number I want to be in there? I'm showing you how to be really lazy. 9, okay? What would that give us? 2x equal, add 3 to both sides, 12, and x equal 6. So when x equals 6, there's 1, 2, 3, 4, 5, 6. We know the y is going to be 3. 6, 3. Okay? What's the next value we want that to be in there? Okay, we did a 0, a 1, a 4, and a 9. Did I hear someone say 16? We want it to be 16. Okay? That would be 2x is equal to 19. X equal 19/2, which is 9 1/2, right? Okay? 1, 2, 3, 4, 5, 6, 7, 8. Somewhere out there is a 9, and that would be that. So here's what my graph looks like. That look 1 to 1 to you? Horizontal line test passes everywhere. Fantastic. Okay? Now, that's the first step. Verify that it's 1-to-1. Okay, I'm going to erase some of this, but not all of it. Okay? Okay. Stop erasing there and go back here. What's our next step? We verified it's 1-to-1. Next step. Second. Okay, that's what we're going to try to get toward. What's our first step to getting it? After we verified it's 1-to-1. What is our f of x? Y, okay. Don't forget the easy steps. Y is equal to the square root of 2x minus 3. Okay? Now, what would be your next step? Change the x and y. So that would be x equal to the square root of 2y minus 3. Next, we need to isolate the y. So we got to start the process of doing that. What would be the first thing we need to do to free that y? Free Willie. Y. Square both sides. Not square root. Square both sides. You got a square root. How do you undo that? Square it, right? So this gives you x squared is equal to 2y minus 3. All right, we're getting close to being able to free that y. What are we going to do next? Isolate the y. Solve for y. Get it by itself. Add 3 to both sides. Okay. So that gives us 2y. I'm moving it over here is equal to x squared plus 3. Right? And now what? Divide by 2. Okay, that gives it to us. Okay, and what is this y? Okay, I know it's x squared plus 3 over 2, but what does that y represent now? We're almost there. Say again? Which function? Not this f. Inverse function. So this is f inverse of x is equal to, and there's a couple ways you could write that. I don't know if you like it that way or maybe like this, 1/2 of x squared plus 3. I don't know. Either way you want to write it is fine. We found it. That's what the next thing we got to do. Okay. We've got to verify. Okay. Now, and how do we do that? Now, here's a timeout here, though. Remember, we're exchanging our x's and y's, right? And right here, we see that all of our y's here have to be positive, right? That means over here, all these x's also have to be positive. If you let a negative x in here, guess what that's going to form? A parabola, which is not a 1-to-1 function. So here, because all your y's are positive, you have to restrict your x's to be positive here. So that's the one other thing you need to say, x is greater than or equal to 0. Why? Because on the function, the y's are greater than or equal to 0. So now in the inverse function, the x has to be greater than or equal to 0. Okay? Now, I know y'all want to do the verification. Yes, you do. Yeah, of course you do. Because that's, might have to do this sometime Thursday, maybe. So you want to try it? Do we have time for it? I don't know. We don't? Okay. Go home and do that. Okay? But let me hint something to you. Okay, yeah. I'm going to show you something. If we were to plot points here, we'll just leave it the same. Plot points here. If we plug in here, say at x equals 0, right? what we're going to get? 3 halves. That's 1 1/2. And when we plot x equal 1, you would get 2. Okay? And if you plotted x equal 2, you would get 7 halves. And guess what? You get exactly the reflection across that. So yeah. What's that? That's okay. No, the best way. Okay. That does verify it for you. If you want to graph those points and show that they're across that line, you can do that, but really you should do the other. But guess what? On the test, all I'm going to ask you for is the inverse function. It's up to you whether you give me the right answers or not. So I'll let you decide. Okay, any of you, I already have one request to see quiz to see what you may have missed. I'll let all of you do that, those who have turned in the quiz. A few people haven't, so you can't see it. Don't let anyone else see it. You don't know who has done it. So anyone who wants to see the quiz, I've got them here somewhere. Here we go. Nakia, you need to see yours, or have you already seen it? It's up to you. Okay, but don't leave the room with it. Just look at it now, and I'll try to answer any questions you have. Okay? Darlene, you want to see yours? Okay. Jermichael, you want to see yours? Did he already go? Corey, you need to see yours? Okay. Hyman, you wanted to see yours? Blair, you want to see yours? Now, please don't leave with these because other people haven't finished. Elena, did Elena leave already? Okay. There's yours. Okay. Jessica, you turned yours in. The other Jessica hasn't. Okay. All right. Yes, there's later. Good deal. Grace, you want to see yours? Okay. Tyler, you want to see yours? Don't leave home without it now. Okay. Tyler, you want to see yours? He's gone already. Sean's not here. Diana's not here. Kamara, you want to see yours? Okay, just lay them flat, face down here. You got it. If you have questions, I can get you maybe later. Brianna's not here. So all of you have seen it, right? That wanted to see it. Look it up. Yeah. Good deal. Thank you.
So all I did was I didn't put it as a negative.
Well,
Like that was right. It just wasn't negative.
Yeah, with a negative there, it would have been right.
Okay, and then here.
I don't know what this means. It's from 0 to 1. That's your interval. That is decreasing. If you had plotted it, it's a, see, this is a function that does like this, right? Okay, so you go up, and that's what, from negative infinity to 0, it's increasing. And here it's decreasing from 0 to 1. And then this one picks up at 1, and that's increasing.
So I got that right.
All right, good deal. Okay. If you want more time with it, just come see me during office hours.
Okay, the exam is Thursday?
Thursday.